I hope you all are doing good. So, in this video, I'll be discussing the sixth question of my data science end semester paper. So, the question says, what are the advantages and disadvantages of using decision trees for classification tasks? How do ensemble methods like random forest and boosting improves the performance of decision trees? So the advantages of decision tree for classification are it is simple to understand and interpret. Decision trees are easy to visualize and interpret as they reassemble flowcharts. Each decision node represents a test on an attribute and each branch represents an outcome of that test. This makes them very transparent and interpretable, which is a huge advantage for understanding how predictions are made. It handles both numerical and categorical data. Decision trees can handle both numerical and categorical features like some other algorithms that require data pre-processing or transformations. It also defines the non-linear relationships. Decision trees are capable of capturing non-linear relationships in the data, unlike linear models such as logistic regression. And then the next is no need to feature scaling. Decision trees does not require normalization or standardization of data, unlike models like SVM or KNN that do not require such pre-processing. Robust to outliers. These are relatively robust to outliers since splits are made based on the thresholds in the feature space and extreme values won't heavily affect the overall structure of the tree. Flexibility. Decision trees can made complex decision boundaries, allowing them to fit a variety of data sets, even with complex or hierarchical patterns. Now we'll see the disadvantages of decision trees. Overfitting. Decision trees are prone to overfitting, especially when they're allowed to grow deep without constraint. They may capture noise in the training dataset as if it were a valid pattern, which reduces generalization to new data. The second is instability. Small changes in the data can lead to a completely different tree structure. This makes decision tree less stable than some other machine learning models. Bias towards features with more levels. Trees tend to favor features with more distinct values, example, categorical features with many unique values when working splits, which can lead to biased models if not handled properly. Limited performance with high dimensions. Decision trees can perform poorly when they are irrelevant features or when the data set has very high dimensionality, that is many features, especially if the trees grows deep and overfit. So basically it creates a very complex structure when you have a very big tree. Greedy nature. Decision tree uses a greedy algorithm that makes locally optimal choices, example selecting the best feature at each split but does not guarantee a global optimal model. Now we'll see how ensemble methods improve decision tree performance. Ensemble methods like random forest and boosting build multiple decision trees to improve model performance. Each of these techniques addresses specific weakness of individual decision trees like overfitting, instability, and bias in different ways. Random forest is an ensemble method that combines multiple decision trees to make a more robust and accurate model. It works as follows. Bagging. In random forest, multiple decision trees are built using different subsets of the data, sampling with replacement. Each tree is trained on a slightly different data set, which reduces overfitting. The final prediction is made by averaging the predictions of all the trees for regression or by majority of voting for classification. So we basically combine multiple decision trees and the final prediction is made by averaging the predictions of all the trees or by majority voting for classification. Random feature selection. Random forest adds randomness to the model by considering only a random subset of features when splitting each node. This reduces the correlation between trees and helps the model generalize better. Improved generalization. By combining the predictions of many trees, random forest reduces the risk of overfitting and increases predictive accuracy. It also tends to be more stable than a single decision tree. Now, the advantages more accurate than a single decision tree, handles overfitting better, provides feature importance which can be useful for understanding the model, Boosting. Example, ADA boost, gradient boosting, XZ boost. Boosting is an ensemble methods that build decision tree sequentially, with each tree trying to correct the errors made by the previous one. Some of the popular boosting algorithms include ADA boost, gradient boosting, and XG boost. Here's how boosting improves decision trees. Sequential learning. In boosting, trees are built one at a time and each new tree is trained to correct the errors of previous trees. In other words, it focuses more on the misclassified data points and adjusts accordingly. Weighted voting. In boosting, each tree contribution to the final prediction is weighted based on its performance. If a tree performs well, it has a higher weight in the final prediction, whereas poorly performing trees have less influence. Reduction of bias. Boosting helps reduce both bias and variance by iteratively improving model accuracy. Since boosting focuses on correcting errors, it reduces biases by learning from the mistakes of earlier trees. Regularization. Modern boosting algorithms like XGBoost incorporate regularization techniques to prevent overfitting, which helps maintain model performance on unseen data. Now we'll see the advantages of ensemble methods. Boosting often produces high accurate models. It reduces bias and variance simultaneously, especially effective in situations where other models fail to capture complex patterns and can handle imbalanced data sets well. Example, in binary classification tasks. Now we'll see the difference between random forest and boosting. Random forest is a parallel algorithm where trees are built independently and combined through voting and averaging. It tends to be more robust to the overfitting and is simpler to tune. While boosting is a sequential algorithm where each tree focuses on correcting the mistake in the previous one, making it more prone to overfitting but typically more accurate when tuned well. So, decision trees are easy to understand, flexible, and handle both numerical and categorical data, but they are prone to overfitting and instability. Random forest reduces overfitting, improves generalization, and increases stability by averaging predictions from many trees built on random subsets of data features. Boosting focuses on iteratively correcting errors made by previous trees, which can lead to more accurate models but requires careful tuning to avoid overfitting. Together, these ensemble methods significantly improve the performance of decision trees by addressing their limitations and leveraging the power of multiple models to create a more accurate and stable prediction. So, guys, this is all from the video. I hope you enjoyed the video. Thanks for watching. Bye.